Hi, in this video we are going to test our application. Again, we are not going to do it and implement it together from scratch because it took approximately 10 minutes to write it out. I recommend you downloading the source code and basically you just have to copy and paste it, or feel free to test this algorithm whatever graph you prefer. I'm going to simulate this graph. We would like to find the shortest path from vertex A to vertex G. It has the mean distance 25 and the shortest path is going to be the A, E, F, C, G. Okay, I think that I had to modify. First of all, we had the typo SH, capital H, and I corrected it to lowercase h. And here we just have to print out the given node. Okay, we have to iterate through all the predecessors, but we have to print it out to be able to track it. Okay, so let's run the algorithm. And as you can see, the mean distance is 25. G, C, F, E, A are on the shortest path. And maybe you can pose the question that, okay, are there any application concerning the fact that with the help of Bellman for the algorithm, we are able to detect negative cycles? And yeah, there's an application for this given case. For example, if you are interested in stock market or the Forex, then you are able to find arbitrage situation. And the arbitrage situations are basically mispricings. So you have, for example, dollar. Let's consider the fact that we have, for example, the United States dollar, we have the euro, we have the Japanese yen, we have Australian dollar and so on, and maybe we are able to buy some euros for some dollars, then we sell the euro and buy some yen, then we sell the yen and buy back some United States dollar, and we end up with more money than we have started. This is what's called a mispricing or an arbitrage situation. And if we have a negative cycle in that given graph, we just have to define basically the euro, dollar, Japanese yen, and so on. This is going to be the nodes. Then we have the conversion value. It's going to be a directed edge between all of these vertices. Then we have to negate, so basically multiply these values with -1. And then we have to run our Bellman for the algorithm and we have to look for negative cycles. So let's suppose the fact that we have, for example, 3 nodes, node 3, and I'm just going, okay, I'm not going to comment it out, but for example, I have the edge 1 is going to go from the node 1 to node 2 with the value 5. Then from node 2, I'm just going to separate it. Maybe I'm going to copy it. I don't want to spoil it in the sense that I'm going to copy it, then I'm going to paste it. So I will have the edge, for example, with edge weight 1 between node 1 and node 2. Then between node 2 and node 3, I will have +1 edge as well. Then between node 3 and node 1, we have to define, is it correct if I define -1? No, because if we sum these edge weights up, it's going to yield a number +1, which is greater than 0, so there's not going to be a negative cycle. If we would like to define a negative cycle, then we have to write it, for example, -3. Okay, so the edge list is going to contain, again, I'm just going to comment it out. And I'm going to define another edge list. The edge list is going to store the edge 17, edge 18, edge 19. And if we run our algorithm like this, it's going to detect a negative cycle. Okay, you may pose the question that it's going to print out twice. Why? Because first we print out when we calculate the shortest path here, and then we print out when we try to get the shortest path. Okay, but what's very important, that we are able to detect whether there is an arbitrage situation on the Forex or not. And with the help of predecessors, we are able to detect that what do we have to buy and what do we have to sell. It's going to show us that, for example, we have to buy some dollars, then we have to convert the dollar into euro, then the euro into Japanese yen, then the yen back to United States dollars, and it's going to be an arbitrage situation. So that's all about Bellman Ford. What's very important that it is able to handle negative edge weights, and because of the negative edge weights, there may be negative cycles. So we have to consider this fact. And another difference between Dijkstra's and Bellman Ford algorithm, that for Dijkstra, we keep relaxing the edges one by one. So we keep calculating the mean distances and the shortest path on a greedy manner on a one by one basis. For Bellman Ford algorithm, as you can see, on every iteration, we relax every single edge. Okay, so that's all about Bellman Ford. Thanks for watching.